still going on. And the city logistic theoretically refers to the planning, coordinating, and optimizing freight and goods movements within urban areas. There are 8 key aspects. Number one, last mile delivery. The second, urban freight distribution centers. The third is sustainable transport modes. And the fourth is smart logistics technologies. The fifth is collaborative logistics. And then regulatory and policy measures. And then micro hubs and local system. And the last is e-commerce impact. I think Prof. Russell, as the one of the experts of the city logistics, will explain us about the aspect I mentioned above. And I congratulate all of you on attending this international guest lecture. Hopefully, what we discuss in this event can contribute to realize that efficient and sustainable city logistics. And it is, I think, it's very crucial for meeting the growing demands on the urban population while mitigating environmental and content issues. Hope we can enjoy this webinar or seminar, a hybrid conference. And thank you very much. And wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Insinyur Sumarjito, for the opening speech. Before the main session begins, we would like to invite our guest lecturer, Professor Thompson, to please come forward, as we would like to give our placards as a token of gratitude, represented by Professor Irawan. Thank you very much, everyone. Ladies and gentlemen, as we move forward with today's program, allow me to introduce our moderator for this event. With a wealth of experience and expertise in the field, allow me to introduce Professor Kunchoro Hertowidodo, who will be leading us through the discussions today. Professor Widodo had his doctorate and master's degree of industrial engineering at Osaka Prefecture University and his bachelor's degree of agro-industrial technology at Universitas Gadjah Mada. Professor Widodo has also demonstrated multiple achievements in the academic field through research, writing, and leadership roles. With his expertise, we can expect a smooth and engaging event as we share knowledge and collaborate. To our moderator, Professor Widodo, the stage is yours.
Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, very good morning everyone. Respectable, honorable Professor Russell Thompson, our guest today, and of course, honorable and respectable Professor Judy, the Secretary of the Department of Civil Engineering, Universitas Gadjah Mada. Thank you for collaboration to have this international guest lecture. And also respectable Pak Latif and maybe all lecturer from the Faculty of Engineering. I cannot recognize one by one here. And also honorable all participants in this room and also in the online room, in Zoom room. Yeah, I hope this international character will be start at the moment. Yeah, Mas MC, can we start now? Okay. First of all, let me invite Professor Russell Thompson to join with me in this stage. Yeah. Big applause for him. Yeah. Yes, before we begin with the material from Professor Russell, let me introduce Professor Russell educational background, short introduction. Professor Russell Thompson graduated from the Bachelor of Applied Science, Royal Melbourne Institute of Technology, and then graduated from Master of Engineering Science in Transport, Monash University, and finally Professor Russell got his PhD or Doctor of Philosophy from the University of Melbourne. And now his position is full professor in transport engineering, especially in infrastructure engineering, in the University of Melbourne, Australia. Professor Russell main research is city logistic, physical internet. What is physical internet? I think Professor will explain to us later. Resilient transport system and intelligent transport system. The latest honor, award and fellowship in 2023, Physical Internet Builder Award, recognizing outstanding engagement and achievement toward building the physical internet. Research grant, a modeling framework for designing more sustainable urban freight system. And he also frequently publish a very great books, and the latest book entitled Urban Freight Analytics, Big Data, Model and Artificial Intelligence, published in 2023. Well, today material is one part, yeah, of Professor Russell Thompson topic of area. So yeah, we can spend our free time to learn from Professor Russell Thompson. Yeah. And before we begin, let me inform the lecture would be going on. How the lecture will be going on? We will have 1 hour or 60 minutes for Professor Russell material delivery, and then there will be around 30 minutes for question and answer. Yeah. So totally there will be 90 minutes for this international guest lecture. Okay. Okay, let's start our international guest lecture from Professor Russell Thompson. To start with, let's give big applause for him.
Pointer? Pointer, thank you very much. Advancing to this one. Thank you, yes, yeah, thank you. So this one goes forward? Yes. Thank you. Distinguished faculty and students, it's a great honor and privilege to come back to the University of Gadjah Mada. Special thanks to Professor Kuncoro Widodo for kind invitation and for all the staff at Bustro. Thank you very much for organizing this visit. It's a great honor to come here, and I will introduce some concepts of physical internet as they relate to the urban freight and the city logistics. It's my pleasure to share with you some of the experiences throughout the world and also in Australia, in Melbourne. Okay. Sorry. Oh. This one? Okay, thank you. Sorry, I just... Oh, okay. Oh. So my presentation will look at the concept of the physical internet and hyper-connected city logistics. I'll look at some modelling approaches and I'll look at some initiatives and applications of these. I always like to start with focusing on the problems. This is engineering department, and we are known for solving problems. And so we must focus on what the problems are. And this list was developed by the founders of the physical internet. And this provides us with many challenges and many interesting problems. And we need to address these in our research in freight and logistics to make the world more sustainable. We know climate change is real. We know this is a big impact, and freight and logistics is contributing to this problem. So we must address these issues. The first one, the shipping air. So we're shipping a lot of empty vehicles, a lot of air. And so there's a lot of capacity and there's a lot of room in our trucks. We have a lot of empty travel. That is the vehicles traveling without any goods, unladen. And this is a very big problem in our cities, creating more pollution and more congestion. And we have lots of emphasis on the carriers. But what is really important is to understand the drivers, the shippers, the consumers, which are creating the demand for freight, and understand how we can change the behaviour of our shippers, our receivers, to make more responsible use of our assets. We know a lot of our assets are underutilised. The vehicles may be only used for a couple of hours a day. The warehouses do not have, they have a lot of capacity which is not used. So how can we more efficiently utilise lots of the resources we have? We know that there's a lot of unnecessary movement. We know the land use, the logistics sprawl in cities, pushing the warehouses to the outer area. This creates lots of extra travel for the trucks and the vans. And so we need to think about land use as it affects the flow of vehicles. We know that the intermodal is a very good concept, and we'll talk more about that, but we know that we need to integrate the different modes, the rail system, the barge system. We also need to integrate with the road system. So we have lots of issues in the cities, and so these challenges are real, and as young academics, young researchers, students, there are lots of interesting problems to solve. So I like, as a mathematics student, I like to solve problems. I like to work on challenges, and there's certainly lots in this area. Oh. Sorry, we do it. Which is, should I point it this way or at the? Okay, so in the urban area, we have more specific challenges. We have a lot of growth. People love living in cities. We all like to live in the city. We can get good access to education, to employment, to the retailing, to good health. And so the city's growing very fast, right around the world. And so we have a lot of congestion as a result of the influx of people. And we also have a lot of disruption due to the construction. We have extreme weather events, and we have special incidents. This creates disruption to our traffic system. And we also have a lot of people using e-commerce. And I suspect it's very popular here to order things over internet. And then it's delivered directly to your door. This creates lots of extra travel and lots of extra trips for the truck trips. And then we need to decarbonise logistics. We need to take the fossil fuels away from the vehicles. And we need to look at more sustainable sources of energy for our systems. So all these are threatening our efficiency, reliability, and sustainability. So some time ago, I was involved in an international study which looked at the city logistics. And in city logistics, we look at the total cost, the triple bottom line. We look at the environment, we look at the social costs, as well as the economic benefits of freight in the cities. And so this is important. And we also look at how consolidation is a very important recommendation 20 years ago and still very relevant today, that we need to consolidate our loads to rationalise the movements and to embrace the technology and the innovation that we can to improve the efficiency of our freight system. So when we're talking about total emissions from the vehicles, we know this is a product of how much pollution, how much emissions are being produced per distance unit, say per vehicle kilometre. But we also know this is a function of how far the vehicles travel, the distance that the trucks travel and the vans. And so with the type of vehicle, this produces the emissions, and this is emissions per unit of distance. But we need to focus on the networks. We need to think about the distances travelled and the origins and destinations and the transfers of our freight vehicles. So network efficiency, the International Transport Forum produced a very good document called Towards Road Freight Decarbonisation. Here we focus on one measure, and this one measure, I believe, is very important for the understanding the sustainability of our whole network, and that is the tonne kilometres divided by the vehicle kilometres. Tonne kilometres is demand. It's how far the goods are moving by weight, in this case, the tonnes. So we all consume, and we all have the goods coming from the warehouses, from the factories, and directly to our homes or shops. But the numerator is the demand, but the denominator, the ratio, The bottom of the ratio is the vehicle kilometres. So if we can reduce the vehicle kilometres, our efficiency will go up. So we need to think about how we can reduce the vehicles kilometres travelled. And this is to try and look at how we can utilise the available capacity, how we can utilise the existing vehicles. So a lot of vehicles are travelling with very small amount of goods within them. There's still a lot of extra capacity for more goods to fit into the same vehicle. So we need to think about how we can utilise the vehicles more in terms of consolidating loads within the same vehicles. And this will reduce the total distance, because instead of vans distributing one or two goods, they will have lots of different goods, and they will be far more efficient, reducing the number of vehicles and the distance travelled. This is a big challenge, and so we need to think about the triple bottom line. And this is a global challenge. And so I encourage you to think about locally how we can address this by looking at more efficient, resilient and sustainable freight systems. Then we'll introduce the concept, the emerging concept, which is a very visionary and very future-orientated concept, but I believe very powerful for solving many problems. This is called the physical internet. So we need to have a global system of interacting elements which interact and coordinated the logistics system in terms of collaboration, in terms of interface between the modular containers, protocols and smarter. So we need more open and shared systems. And this is the future of freight. We see examples of this. It's a very idealistic, visionary concept, but we can all help implement elements of this area. So the physical internet. So we need to transform the way that our goods are moving around. At the moment, we have individual players trying to optimise their systems, but we need to think in a global and holistic perspective. We need to think about how we can share and collaborate and integrate more within our networks. So the first concept is open and shared networks. We need to open up our networks. The shippers, the carriers, the transport companies need to open up their networks so we can get this collaboration, we can get this consolidation levels higher. We need standardised units to be able to allow us to swap and to transfer the goods between vehicles at particular terminals. We also need to have visibility, and we know this with the internet, with the IoT sensors, we can track and trace where our goods are. And so we need also new business models. And this is a very good area because this brings in not just engineering, but the business, the management. This is very good for multidisciplinary research to work together to solve these very challenging problems. And so we look at how we can integrate these concepts of the synchromodality in coordination and synchronization of the exchange. We need city logistics, the triple bottom line. We need safe and sustainable. We need coordination, and we need to use IT in these networks. We also have the load unit, which can be compatible, which they can be mixed and matched and consolidated within vehicles of different types of goods. So the features of the PI is that we need to think about not the right load for the right vehicle or the right mode. We need to think about multimodal. We need to think about different modes. We need to think about number of modes and high load factors, high utilisation of vehicles. So this will involve multiple vehicles, maybe electric vans, trucks, vans, walkers, and we need even electric bikes. So we need to design networks which are multimodal, integrated with a number of different modes. One vehicle cannot do all the work within a city. It cannot go across the city and be efficient. It needs to transfer, it needs to be integrated with other vehicle types. And so we need to think multimodal. And we need to think about integrating different loading docks and transfer facilities. And we need to think about how it interacts with different people, different vehicle types. And so the concepts of trying to integrate and coordinate these activities. We need to think about the elements of the physical distribution network, that is the containers, the load units, the nodes, the transfer hubs, and the movers, the vehicles, and look at this as an integrated network. And so we need very good ways. And then we introduce the concept of hyper-connected city logistics, which is this physical internet applied to city logistics. So the ALICE program says that we have lots of challenges to achieve the physical internet, and we have lots of steps, and we must, in our research and our development, approach these different areas to make sure we can integrate and develop this holistic approach to freight. And this is global freight, but also at the city level. And ALICE, which is a European Union research program, have identified a roadmap. So the physical internet will take some time to implement and develop. And so there are various stages that will be necessary to achieve this high degree of integration, coordination, and sharing. So there's different steps, and I encourage you to look for this in your research and your studies, how you can help achieve these various milestones, these various activities, which will be necessary to get this fully integrated, fully coordinated global system. And then the hyper-connected city logistics is to really look at a network of terminals and vehicles that can work together to transfer the goods within, without, and outside, within, and into these urban areas. And these is where we live. And a number of different types of terminals where transfers occur. And this transfer will involve exchange of goods from one vehicle to another, and usually one vehicle type to another vehicle type. We have high capacity vehicles, big trucks, and we have smaller trucks, medium-sized trucks. We have walkers, electric vans, all integrated in a network which can achieve this high utilization of the vehicles, and can eliminate a lot of unnecessary empty travel, unutilized vehicles. And so this involves a network of terminals and integrated system of vehicles. Just an example, in Melbourne, a metropolitan area in Melbourne where the shops are. So this is a network of shops, retailer, large retailer chain, and throughout the metropolitan area. So the left diagram illustrates that a warehouse needs to get their goods to each of the shops, supplying the shops with the goods. And so on the left side, it could be a direct distance, travelling to each shop individually, or on the right side, we could do a series of routes or runs, daily runs, to visit a set of customers and deliver the goods from this warehouse to the customers. And each petal, each route is quite efficient for this warehouse, this shipper who's got a warehouse in Scoresby. And so, but the trouble is we have many warehouses supplying these customers, these shops. So there could be a warehouse in the southeast, but also in the southeast again, east, could be north. So there's many warehouses, and they're all distributing their own goods efficiently using these daily cycles of delivery routes and optimizing their network. And then we could introduce a two-tiered system where the first tier is an exchange between the warehouses. The goods from the warehouses can be exchanged at a central warehouse in the Scoresby one, and then the goods can be exchanged there and brought back to do local routes. And so this is a very efficient way of reducing the transport. The first stage is to take the goods from your warehouse to another warehouse to do sorting, and then local routes can be developed from the warehouse to do more efficient and shorter routes. Now this is a sharing type of model, similar to the physical internet, and this achieves huge savings. This saving is in the order of 78% of distance travelled. So this is remarkable in terms of the total reduction in terms of total travel distance by these trucks. just by sharing and exchanging goods at one nominated warehouse. And the other interesting thing about this example is this does not require any new facilities, so we're using existing warehouse and existing vehicles. So we can save 78% of the distance travelled, which means 78% less emissions, reduce congestion if we implement this type of system. So this illustrates the power of the physical internet, the power of sharing, the power of collaboration. And so we need to think about what we should do. So we need to think about lots of goods, as we said, are coming back, congestion is real, and this can be a real how we design these networks. So this is a good research area. And so performance measures. How do we measure the performance of the global or the holistic system within a city? Looking at all the movements. And so we looked at that network efficiency. We look at load factors, which has to do with the utilisation of individual vehicles of their routes. We look at the work, the amount of deliveries by distance. We look at the laden vehicles, the ones that have got goods in, and we need the number of departures and arrivals. So in logistics, lots of the movement patterns have concentrated on long distance, where the high levels of consolidation occurs between the different nodes. And there are lots of interest in maximising the use of our railway carriages and our large trucks and our ships that are going between these nodes. So we need to adopt a similar type of system for our urban freight. So we need shared vehicles, and we need to develop a way of integrating different vehicle types. And in this case, I'll look at another example where we can look at the travel between different industrial and production areas in a city. And so if we look at how we can move things between areas for production, we know that there's a lot of vehicles travelling from the warehouse to a customer and coming back empty. So the white vehicles are carrying air. It's very inefficient, coming back unladen. And so this is quite typical in a lot of cities where the delivery will go between the factory and the warehouse, between factories, and coming back empty. And so this creates lots of extra congestion. So how can we solve that problem? We could solve that problem by doing a shuttle between these areas. So we could do the local pick-up and drop-off using smaller vehicles, and we could do the travel between these freight areas using larger vehicles. In Melbourne, Australia, we have large multi-combination vehicles that can operate on our main roads. And so this creates lots of less travel and creates lots of utilisation and eliminates the empty running of those vehicles. And so to illustrate that, we have lots of industrial areas in Melbourne where the factories and the warehouses occur. And so we have a network of these, and there's a lot of travel in between these. And so we did some modelling to look at the way this network could be developed to exchange the goods between these areas using a shared system. And so the total distance travelled by the type of freight was from 190,000 vehicle kilometres and down to 27,000. So dramatic change, about 70% reduction if we have a shared system where we use the larger vehicles to transport the goods between these large freight areas in the city of Melbourne. And so this is a very good story for collaboration, a very good outcome. This can solve lots of cost, lots of congestion problems. This can actually solve lots of emission problems as well. So we can also look at the swaps. If we find that goods need to be moving around between stores or between factories, we could do this in many ways. Each store could have their own vehicle which visits every other store to pick up and drop off goods from that store. So in a simple 5-node network, we could have each store having their own vehicle. So 5 vehicles visiting 4 stores. But this is a very efficient way, is to create a hub at one store. And this can dramatically reduce the distance travelled because the lines represent the distance travelled by vehicles. So vehicles can go from each store now into the central store and do a swap, exchange, and come back with the goods destined for their store from other stores. So the exchange occurs in the central warehouse. So again, this dramatically reduces the amount of freight travel and the amount of freight distance travelled. So there's different combinations that we could do with less trucks, coordinating some exchanges at various shops to pick up and drop off the goods destined for other shops. So they could visit smaller number of stores, or we could have more vehicles visiting less stores. This one is also very good. We could have one vehicle doing everything and visiting all stores and dropping off goods and picking up goods and doing one route. So this is one vehicle picking up goods at stores, dropping off the goods at the stores, and doing one route. And so there's various combinations. So when we think of a network, we need to think about how performance could be measured, particularly for sustainability. And so we now think about what are the criteria. Could be the load factors, could be the number of swaps, and each stakeholder will have different criteria. And we quite often think about the administrator because the government represents the people, the environmental, the social costs. So total distance travelled and network efficiency. But if we're a carrier, we maybe think about the number of vehicles we need or the load factors. If we're receiving goods, we think about the arrivals and the number of swaps. So we did a comparison of those networks and we looked at the contribution of those. And so we found that the one vehicle visiting all customers performs very well, but so does also the 4 vehicles with a central hub. So it depends on which we are trying to emphasise. So we think about if we use a uniform weight for each of those criteria, we find that the one vehicle servicing the 4 shops. But if we look at the administrator, in terms of their emphasis on the distance, the shortest distance route is that central hub. And the central hub is very good for reducing the distance, therefore administrator is very happy with that type of network. So how can we promote this type of network? So we look at swaps where these occur within the different networks, and we can have lots of vehicles with all the shops and all the facilities having their own vehicle, or we could have that transfer hub. And then we could have various ways of coordinating this. And we could also look at multi-objective programming to look at the trade-off between the number of transfers as well as the total distance or financial cost. So we have done some modelling to look at the trade-off, and we can identify solutions which number of transfers can be expensive to transfer the goods. It can be the reliability issue, so we maybe want to limit that, and then we can still work out the most optimal route. Another illustration is to look at a courier. Couriers in our large cities, they do an outside run in the morning to pick up the goods in the metropolitan area, take it back to the depot, and then do a distribution run to the central city area in the middle. This is a common type of courier service operating in our big cities. So this is one company visiting customers in the morning to pick up and then taking the goods into central city area. But also we have many companies, and sometimes they have depot in different location, and they will be picking up the goods and dropping off the goods in the central city area. But you can see in this case, this is conceptual, there's lots of customers near each other. So we think, wow, let's think about, but then we have more. And so this is very expensive in terms of transport distance. So if we think about, we can transform it into this type of network, where each depot agrees to pick up the customers near their depot to pick up the goods. And they can use electric trucks or vans, or even sometimes bicycles, because it's close. It's close to their depot. They can pick up the customers' goods. They can take the customers the goods into the central area, and they can use locker banks to transfer the goods, exchange the goods with a local operator operating within the central city area. And this could be bicycle, could be pedestrian, or could be some electric van. So this is a very efficient way of reducing the amount of transport, again, the distance travelled, by collaboration, and everyone wins. The operators have less cost, the shippers get less cost, and it's very good for the environment, very good for sustainability. So we developed models in our research to try and facilitate these types of programs. And so we are using agent-based modeling, and we are using optimization to build in the behavior of the different actors, the shippers, the carriers, the receivers. And we developed this framework for integrating the different players and how they interact, because they will have some financial relationship, they'll have some contract obligations, they'll have to interact with the system. And so we have real-time information, and we introduce the concept of the digital twin to integrate this in the hyper-connected city logistics. We also use synchromodality, and I'm proud to say we have a PhD student from University of Gadjah Mada, Sekar Sakti, who is actually currently studying at the University of Melbourne. I'm a supervisor, and she is involved in the synchromodality. And so she developed agent model to look at the interaction between the players, the shippers, the carriers, the receivers, for synchromodality, which has to look at intermodal transport and to try and look at how we can integrate better, particularly when there's disruption. And so some agents will be learning, some agents will be interacting with each other, doing contracts, doing exchange, and this is a very complex system of interactions, but we model this to try and understand how we can improve the behaviour and the sharing of resources. And so the total costs can be reduced. And so this is a very good model, and Sekar has a paper in the Transportation Research Part E, which is a very good review of the different models and the different concepts. She developed this model which looks at the different types of players, the different types of actors. We have transport companies, we have railway companies, we have different modes. We have the administrator trying to set the rules and infrastructure. We have the shippers who want their goods to be delivered on time, reliably. And so as we understand the financial flows, the freight flows, and the information flows between these players, we can develop better systems for interacting, better systems for ensuring that our freight is more efficient, more sustainable, in a very dynamic environment where we know there's lots of delays with the extreme weather events, and we have flooding in Australia, we have disruption to do with the extreme weather, and so this can respond very quickly to the different players. And we also think about the hubs, the transfer facilities, because the coordination necessary at the hubs, the exchange points, the terminals, is very important. So we need to integrate and we need to coordinate the carriers. So some carriers will be coming to actually drop off goods, and some carriers will be receiving goods. Some will be doing both. And so we need administrators, we need standards to exchange information. We need to think about how we can predict the arrival times so we can exchange the goods very efficiently, and maybe some short-term storage. So this is a very complex model, and so we have papers which try to develop models to try and reduce the delays, reduce the congestion, and improve the coordination of the vehicles coming to exchange the goods. And so we know traffic is very unreliable, very uncertain, the travel times, and so we have to predict using different models, and we have to understand how we can coordinate and integrate this. And so we understand in logistics, there's different types of decisions over different time frames. So some are day-to-day, short-term, operational decisions. Then we have the tactical ones, which are more medium terms, weekly or monthly. We need to make decisions about workforce and different facilities. And then the long term, we need to think about warehouses, we need to think about policy. And so different players will have different type of decisions at a different time frame. And so we need to think about how these can be integrated, how they can be coordinated. And so we need to think about how we can model the city logistics to consider each player and the different types of decisions and how they interact with each other. And so we come up with the multi-agent system. The multi-agent system represents a simulation environment where we can simulate the activities and the decisions of individual players. So we have administrators, receivers, carriers, and shippers. And we have different options to consider. We can have parcel lockers, We can have the crowd shipping platform. We can have different consolidation centres. So we need to think about how these new types of operations can affect the different players and how they order and price and interact with the goods movement. And we develop models for trying to interact. And so there are many papers that we produce to try and understand the dynamics and how we can improve and increase the sharing. One of my PhD students developed a model for, instead of, we have express delivery, so pick up and drop off within the city. So this could be parcel or small goods, and we call instant delivery. And so if we use a parcel locker to exchange the goods, the routes can be lowered because some vehicles will need to travel a long way to pick up or drop off, and we could integrate this with another vehicle that maybe is already operating in that area, in that part of the city. And so by using the transshipment node, say parcel locker, the goods can be exchanged and the routes can be considerably lowered in terms of their distance travel. And this introduces, how do we promote this exchange? How do we actually operationalise this concept of being able to transfer to more efficient vehicles? And we introduce auction system, an online auction system, because we need some way of interacting with the pricing and the financial transaction. So we simulate auction system. An auction system can connect the shippers, the carriers to each other, and they can negotiate the price and the conditions of transferring the goods. And so this is very important. So we develop auction system to try and allow this exchange to be done in a very rational and a very efficient way. So we look at different types of auctions, and there are different types of auctions that we can do. We're probably all familiar with eBay auctions, but in this case we're looking at auctions between carriers and auctions between shippers and carriers. And we need to understand the pricing and the costs of the different players. And so we develop algorithms for trying to optimize the routes, because the routes will change. Some new nodes, some nodes will be deleted from the routes. And this happens very quickly, because we know that in a dynamic that there can be new goods, new types of carriers, and so this has to be done in real time. So our models have to be very quick at updating the routes. And we look at B2C, consumer to consumer, and both omni-channel type of networks. So we've looked at this, and we found that the auction system with a transfer hub reduces the costs for the carriers, improves the profit for the carriers, because instead of the carrier having to go to some node which is very expensive and a long way from the other customers, they can hand over to a carrier who can do this far more efficiently. So the carriers win. The auction platform also makes a profit for organising the auctions, but we also look at the distances and the toured lengths, and the auction system reduces this considerably because the routes can be far more efficient. And this is a very good story for the auction system and the transfer hubs in a type of delivery system. We also use this auction platform to connect, as I said, the carriers and shippers. And we introduce a model where the bidding is undertaken and online, and we can simulate this, and we can simulate the transactions and the changes to the routes that are performed. And so this is very important to understand the different effects of each carrier offering work and bidding for new jobs that they can organise more efficiently. And so we did some modelling in Melbourne, in the metropolitan area with 3 carriers, and this one we used artificial intelligence. We used machine learning, because we find with these models the carrier is usually not that very good at calculating different changes in costs, different timing, and how to price with a different change. If they accept a new good, how's it going to change their route? How's it going to change their costs? How's it going to affect their profit? The previous one, we had rules about profit margins, profit and cost, but in this case, it's very difficult for the carriers to be able to calculate the costs in real time. So we actually automated the auction system to give the good bidding based on historical transactions. So machine learning can help us, these very complex and dynamic, but also using historical patterns. And the scenario 5, which is the one where everyone has the machine learning, we can see that one is actually a very, very good one. So it actually has the best profits for each carrier, because if we're doing this calculation, if the computer can calculate all the marginal costs, all the changes in costs very quickly, it offers the most efficient bids and the work can be gained. So actually the carriers make more profit, the tour length are reduced, so in the purple line is the scenario 5, and this is when everyone is using machine learning. And also the emissions are much lower and everyone wins, which is the goal of city logistics, is to improve the economic, social and environmental. So we have a good outcome for emissions, we have a good outcome for the profit margins, and we have a good outcome for the platform. So this is a very, very good result for machine learning with the auction system, allowing these transfers to occur, and everyone wins. So this is a very good outcome for modelling, but for this type of network, and also for the implementation of AI. AI is the buzzword, and we should be embracing AI, and we evaluated this, and the AI system is very powerful at making very good decisions, ensuring that all players are benefiting, and as well as society. And so we also look at crowd shipping. I don't know how popular it is here, but we can use the crowd, the public, we can use the private people to deliver goods into local areas. And this can be done by coordinating this at the public transport terminals, where they can pick up and drop off the goods, and the last kilometre can be done by the public. And so the platform needs to offer these jobs, and with apps on our phones, we can accept work, we can pick up a parcel, we can deliver it, and we can make some income. And so this can reduce the number of van trips, particularly in the local area, the number of truck trips to the household. And so we've been developing models that can help us develop a very efficient way of exchanging goods and transferring goods using public transport, using the private population. And so we have done the modelling to do with the different type of networks. On the left-hand side, traditional network using the vans going to all the households, and then we can integrate this with the public transport terminal and integrate this with the walkers, and we can considerably reduce the distance. And so this is a very complex model with the different decisions by the private people. How much are you willing to share, to participate, how much revenue you want. We have to have the shippers understanding that we have to have checks. The platform will offer these jobs at certain rates, and this can efficiently reduce their travel. So we also did work in Sydney with COVID. COVID came in and everyone had to have their deliveries directly to the home. So instead of going to the shop or the central city area to get the goods, things were delivered directly to the households. And so this, of course, increased the amount of trucks operating in our metropolitan area to the households. And so we find that the new concept is to try and build a network of smaller terminals in the metropolitan area to try and encourage transfers so that the vehicle, the trucks, the vans don't have to go into local streets, into the residential areas. And so we looked at the different time limits that it takes to deliver within these local areas. And so we developed a model to look at the location. And in Sydney, a large city in Australia, we have a very large metropolitan area, and the sudden shift of the goods from the central city area and the main shopping areas to the suburbs. So we developed a model to look at where we should locate these hubs, these what we call micro-consolidation centres, so that delivery vehicles don't have to go all the way into local areas. They can deliver to these nodes, and then from these nodes, bicycles or small vans, electric vans, or even sometimes walkers can actually utilise and do the last kilometre. So this reduces the total distance travelled again dramatically. So we looked at models, how we, different numbers of centres, because we have to work out the best location, the best number of these smaller hubs, and the trade-off between delivering to a number of hubs for the warehouses, as well as the reduced travel distance by the local transport. So we look at the trade-off to try and optimise the number of centres and the number of actual facilities and the location. And so what we found is that goods follow people. So we have to understand the purchaser, the consumer. And this is very different than before. In logistics before, all we had to work out was where the shops were or where the terminals were. But now we have to understand where people are. Shopping, they're at work, they're working from home, they're at home, they want the goods at home. We have to understand where they're travelling to for entertainment, because they can pick up the goods at different locations. And they request quickly, they want the goods quickly to be delivered to the household, quite often. So goods follow people. So we need to understand the personal activities. We need to understand where they are, what they're happening, and we need to transform, develop tools to transform to very micro network of hubs. And so finally, the research directions. We need to think about what are the tools, the latest tools, and the concept of digital twin is very powerful, combining the agent modelling with the IoT sensors with AI, automated decision making. So this is a very powerful tool for implementing these ideas. And so we're developing models using this framework to try and reduce the costs, transfer costs at terminals, to try and reduce the costs of transfers and allow that integration to occur. We also need to integrate behavioural choice modelling with optimisation, because we need to understand the consumer, we need to understand the public, and we have different types of rules, we have different behaviour, we're all different. We have different patterns to organise our logistics. And so this is important to understand. We can't ignore the customer and the characteristics of the customer. And then we develop networks to optimise and reduce the travel distance based on our understanding of consumers particularly. And then we think about multi-objectives, because we have we have time, we have money, we have emissions, and we have pricing. So we have different performance measures, and we need to look at the trade-offs. And so multi-objective programming is very appropriate. And we need to think about integrated planning, because we have a big energy problem. We all like to drive electric van or electric cars, electric bikes, but these are difficult to get the power, to get the charging, to get the different infrastructure. So we need to think about energy, and we need to think about low emission energy or zero emission energy. So we need to think about electric vehicles. We need to think about hydrogen vehicles, biofuel type vehicles. And then we need land use. As I said, we need to think about the city, where the industrial areas are. This concept of logistics sprawl, making all the warehouses and terminals away from the city centre. This is very bad for logistics, because the goods have to go in and out many times. So we need to protect. In Paris, they're building new facilities in the inner area for logistics to coordinate the transfers, to eliminate the trucks having to go in and out and around. And so this is very important. We also think about the micro-mobility, the smaller vehicles. The very small vehicles are very efficient at the local level, at the precinct level, at the last kilometre. And we need to combine this with the crowd shipping. We need to think about revenue management, because the carriers want to make money. They operate in a profit. They need to make profit. So we need to understand that. We need to understand their costs. We need to understand their profits. We need to understand their practices, how they can price, how they can interact. And so this is very important for city logistics, to understand the way that the carriers can actually participate, making financial decisions. And also the crowd will need some willingness to share, willingness to participate in the crowdsourcing. And so finally, I have a number of papers that I'm very happy to share this presentation with Professor to distribute, so I can make these available. But a lot of the work, the models that I talked about, we have done a lot of modelling, a lot of research, a lot of analysis, and so I've only presented a very high-level summary. But hopefully that this gives you some appetite, some overview, and you can look at the number of papers we have which can illustrate in detail the mathematical modelling, the analysis, and the way that we've been able to try and to do some case studies to implement this physical internet concept in the city logistics. So again, it's a very great honour and privilege to be here, and thank you for the opportunity of sharing. I'm very happy to take some questions. Thank you.
Yeah, thank you, Professor Russell Thompson, for your very informative and very comprehensive presentation. Yeah. Dear all participants, now we will enter to the question and answer session. Yeah. We will give opportunity put for the participant in this room and participant in the Zoom room as well. Yeah. Okay. So we plan to give opportunity, three person to give question in this room, and one until two question from the participant in the Zoom room. Yeah. So around 3 to 5 total question for the participant. Okay. First, let me know the question from this room. Who will be? Russian, please. Okay. Yeah. 1, 2, 3. Yeah. Yeah. Nice. And also thank you for all the participants for your very active participant in this lecture. Okay. We will let you to convey your question, and for this, let's discuss one by one question. I think it's better. Yeah. So please, the first question for you. Yeah. Please introduce yourself. Yeah. Who are you? Where you come from? And what question you want to know? Yeah.
Okay, so first of all, thank you so much for this opportunity. My name is Jeki and I came from a master degree of industrial engineering of Universitas Gadjah Mada.
Okay.
Actually, thank you so much for these presentations, Professor Russell. So I think this is really intriguing and really exciting to know about urban city logistics. My question is based on what's your research and based on my experience regarding this urban city logistics, because from what you've been presenting, that sometimes it's much more efficient to make it like a shared network between one depot and also for the other depots. But my question is that if we are doing the sharing parts and then there is some problems with the other depots that makes those depots cannot delivers the items in times, how can you consolidate those kind of problems into like making still the very efficient way for the other depots to make a turn and make the delivery in times like that? Because as we know, from one depots and the other depots, they have their different objectives. And then if we're depending on the other depots, then we're also expecting them to carry the items in time so we can get back to our depots also in times and share and fulfill our objectives. And so based on that, how can we consolidate and how can we measure the limiting times for those late deliveries by the other depots like that? Thank you so much. That's all from me.
And question. Okay, Professor Russell, your time to respond to the question.
Thank you very much. It's a very good question. I think the concept is to try and share information So we live in the digital age, so we have apps and we have good sensors and we have very good real-time information about the location and the demand. And so I think the way that we can address the maybe equity or some issue to do with the different types of facilities maybe being impacted is to share information and to have platforms for engaging and visibility. Because if we are going to look at some change, we need to know, why and how much it's going to cost and the benefits. And this is all very achievable now with the internet, the digital internet, with the IoT sensors. So we need to create more platforms, and a lot of our research is now looking at how to create a platform to share information, because the demand patterns will change very quickly and dynamically as congestion or disruption or some delays occur, we can quickly respond. And so we need models, we need information, platforms to share. And this is all very possible now because we have the technology. So we need to set up ways of understanding what is happening. We need also predictive models. We look at prediction using AI to try and predict the delays, predict the travel times. We need standards to coordinate because the goods will have different origin, destination, different features. And so we do work with the GS1 standards company that has global standards for exchanging goods and exchanging information between carriers and at terminals. And so all this can be updated in real time. And so it's possible. So we really need to just develop the platforms for illustrating how and identifying where opportunities are. So we need this responsive system, and this is where revenue management is good, because we need to understand that the different pricing, the different cost impacts, and artificial intelligence, as I said, can really help as well, because we can predict, but we can also make the artificial intelligence can help us make better decisions, because these are very complex networks, they're very dynamic, and we need to be able to respond quickly. And so I think the digital technologies and the software platforms are very important for us to connect the different players and to show where and have a very flexible and dynamic system which can achieve these goals and of increasing the utilization, consolidation, but to do this in a way which is still competitive. So we can still have interactions, we can still have negotiation, we can still have some auction, and still that the players can still make a profit.
Information and response from Professor Russell.
Yeah, absolutely.
And any feedback?
If I may, can I ask what is that? Like the updates of the questions that I said before. Yeah. So thank you, Professor. I totally get it now. But if I'm not mistaken, that you say during with your research, you've been using AI also to calculate and make the decisions based on the problems that are currently going on. I want to ask, how effective is those usage of AI in terms of like making the decisions? Let's say in examples that in Indonesia itself, we are currently facing a lot of like natural disasters like that, and sometimes it's happening really instant. So we sometimes without even warning or something like that. So based on that, how effective this AI decisions making in terms of like making the best and most efficient way for the deliveries and also for the cost-effective ways like that. How effective the usage based on your experience in using that? Thank you.
Yeah, but the AI is very powerful because the AI can get real-time information and can update very quickly and can use all this environmental information and data to respond. The physical internet is a distributed network, and so this can adjust very quickly. So if one node or one link is unavailable, is broken, and it can quickly respond by advising about the change. And so AI is a very powerful tool for predicting and also adjusting the and recommending the appropriate response. So I think AI can be very big help for us. Sometimes we're scared of AI because we think it may be taking control, but if we give it the right information and we give it good rules to ensure that equity and good business principles are applied, as we've seen with the online auction, it can actually help all players benefit. So if a disruption occurs, we need to then adjust and it can advise and it can help us adjust the disruption. This can eliminate a lot of delays, a lot of disruption costs, and so AI is very flexible, and so I think it's a very good tool for combining lots of different type of information and advising us. So I think we should be very interested in the potential of AI.
Okay, thank you so much. That's all for me, Professor Russell. Thank you so much.
Okay, thank you, Mas.
My name is Jackie. Jackie.
Okay, thank you, Mas Diki. Yeah. Okay. Now we move to the second question. Please introduce your name and your where you come from. Yeah, from UGM, betul? Yeah. Okay. Please your time now.
Okay, that's. First of all, good morning, Professor Russell and Professor Kunchoro. Thank you for the opportunity. I'm Ananta, and one of the students of civil engineering in Universitas Gadjah Mada. And thank you for the interesting and informative presentation. One of the things mentioned was how to utilize different depots on various areas of cities to exchange goods and deliver them more efficiently. But in Indonesia, we have a lot of shipping services and their own different warehouses and couriers. And so my question is, how can we convince these different shipping services so that we can use the different depots and warehouses in an integrated collaborative system? That's all from me.
I think I understand the question. Thank you very much. A very good question. It's very different thinking. The old thinking is that we have to control everything, independent company controlling everything, their own assets particularly, and pricing, but this is very bad for the total efficiency. So we need to create platforms and mechanisms for facilitating sharing. And this is very important because a lot of warehouses, a lot of terminals are underutilized. So if we change the thinking of the company, that can be actually used. That can be actually profit area. So if we open up some unused, so warehouse sharing is very important because these are the terminals where we can exchange and short-term storage. So we need to open up these assets, particularly the warehouse and depots that can be used by others. And this can be extra revenue for the company. So they still have control, they still can, but they can get some revenue for this utilization because they have excess capacity quite often. And so we need platforms for facilitating the exchange, the transaction. And so a lot of warehouses now are starting to think that instead of having empty area, they can use that area. They can use that area to actually allow other companies, not competitor, but other companies that could use this, and they could operate there because they're already invested, so they can get some extra revenue, and the other companies can also make money. So they can do some transshipment, they can do some exchange. So they will save money, but the current warehouse can make money. And so this is important. So we need to change the thinking that we need to control everything, and also the utilization for the warehouse particularly. It's very bad. We create the warehouse mainly for the peak or the surge demand, but other times it's maybe empty. And so we need to encourage those companies to offer their space for short-term rental, for transaction, and they can make more revenue.
Yes, I think that answered my question. Thank you so much.
Okay, thank you. Thank you, Mas Ananta. Yeah. We have one question. One question remind, but actually we give opportunity for two questions. Yeah, two questions remaining. Yeah, in this room. But let me give opportunity the question from the Zoom room. Yeah. According to the information of the official, there are two questions. Yeah. First from Pak Rudi. Ya. Pak Rudi, halo Pak Rudi. Can you hear me, Pak Rudi?
Yes. Is my voice is clear?
Little louder. Can you
Okay.
make louder your question?
Okay. Is it okay now? Is it okay now?
Okay. Please, now your time. Yeah.
Yes. Thank you, Prof, for your explanation. I have some question. In sharing concept, there is a consequence to upscale the track, which also upscale the infrastructure, such as road capacity. Maybe this is easily implemented and success in some region, especially in Australia. But in many regions in Indonesia, we have limit road capacity, and to the situation, how do we approach to implement this concept in many regions in Indonesia, which limit capacity and limit width of the road. And then number two, from my point of view, there should be three parties in this business, maybe to accommodate the business that exists. So there has to be a third party in this business. So how do your point of view in the new business model if we implement this concept in tight and route competition of the logistic business? And number three, how the government involve your suggestion to government, to official, to increase and to push to speed this concept implemented in Indonesia. Thank you. That's all three questions.
Rudi, ya Pak Rudi came from East Kalimantan, East Borneo. Yeah. Yes, the staff of local government, transportation local government of East Kalimantan province. Yeah. Okay. Did you get
Yes, thank
the
you.
idea?
Very good questions, and I tried to address each of those. The first question, I think, looked at the infrastructure capacity. With the physical internet, it is very powerful to utilize the current capacity, the current physical infrastructure, because as we know, it's underutilized, but it's the vehicles that we need to focus on. So we need to think about the trucks and the vans and the different freight vehicles that we can increase their utilization, and therefore we will reduce the demand and therefore reduce congestion. So we need platforms to connect and to try and encourage the load sharing and the cooperative freight system to reduce the amount of vehicles, particularly empty running and running with a very small number of goods. So this is actually very good for infrastructure. In terms of existing infrastructure, can be utilised. We don't need a new infrastructure. It's trying to influence the load sharing and the joint delivery systems and facilitate this to use the existing vehicles, and this will reduce the demand and congestion and cost, and then for our transport links should be sufficient to cater for this. And your second question, I think it relates to the way that we interact. We need platforms, I think, to connect the players. We need a way to interaction for us to interact, and this is very important. I think the second question was more about the contribution of
party.
The
Third party. Yeah.
third party. Well, this is important because we need coordinators. We need new organisation to link the shippers and the carriers. So we need a new organisation to develop the platforms and to engage with the carriers and the shippers, so to coordinate and to integrate. And so this is like a new player. So the third-party logistics company is just one company, but we need a high-level coordinator to embrace these companies and to offer the work, to look at how we can coordinate and exchange the different type of goods. And so this is a new player that can be negotiating with the third-party logistics, can be negotiating with the carriers, and to bring the different shippers together, because this is very important to link them. And the third-party logistics company is just trying to maximise their network. But we have many different third-party logistics companies, and we need to integrate those. And so this is a very important way to try and focus on how we can connect these with a new player. A new player can offer the different incentives and offer the different contracts, and very flexible, very dynamic between the third party and the smaller operators, and to do this in a way which can utilise the capacity of the third-party logistics companies, but also the needs of the shippers and the customers, and to do this in a very flexible, dynamic way, because we have lots of different change, and we must respond very quickly, dynamically. And so the physical internet can, through platforms with the new players, coordinating the different players and facilitating their interaction. And the final...
But could you please explain to us, when we are talking about city logistics, who are the participants and how all of the participants should collaborate each other, including the government, and in this case, the local government of East Kalimantan, for example, when they want to do any city logistics in the province, for example.
Yes, no, the local governments and the government are very important, because the government can provide some new infrastructure. We think about ports, and the government provide the port area and manage that. But we think about in city logistics, the micro consolidation centres. The government can provide this land and this area to facilitate the exchange. And this can be handed over to private sector to manage, to organise the transfers, to exchange. And this is what's happening in Sydney. Those new micro consolidation areas in Sydney, the government is looking and investing and transforming the areas and the facilities so they can be used for logistics. And so the government has a very key role in facilitating and also allowing these new terminals, the smaller terminals, to be utilised and developed. And so we need land use planning that allows these small transshipment centres, we call micro consolidation centres, to be set up. So they need the public funding for the space, they need the zoning, and they need the government to facilitate, provide some base infrastructure. And so this is a new infrastructure, because currently the government thinking probably more about the links, the freeways, the roadways, but we need to think about more the smaller terminals, and the government getting involved with it in Sydney. New South Wales government is involved in planning small terminals, network of small terminals. And this is new thinking for government to provide new terminals. We did the modelling about the location and the number, but then the government will invest in these smaller areas, smaller terminals, to allow the physical internet to operate. And so they have a very important role, but it's a new infrastructure, because we need to change the thinking of government, because sustainability is a real problem. And so we have to have new thinking, we have to have new systems, and the government must also think differently. And in Sydney, after COVID, the government is very worried about the increased congestion, increased number of trucks moving around. So they're thinking we need to provide some new facilities, And we need to provide those new micro consolidation centres. And they're only small facilities, but they're very important to allow the exchange, to enable the physical internet to be realised.
We hope, Rudy, you can get the idea. Yeah.
Okay, yeah, it's enough. Thank you.
Okay. Thank you, Pak Rudy, for your good question. And now we move to the second question from Zoom room. Yeah. Mas Fikri, ya, Pak Fikri. Sorry. Yes, Pak Fikri Amori. Did you hear me? Pak Fikri, Mas Fikri?
Yes,
Can you hear me?
is my voice audible?
Can you hear me? Hello?
Yes, I can hear your voice, Professor. Is my voice audible?
Bisa dibantu nggak ya di Zoom? Oke, ya. Oke, Mas Fikri, can you introduce your name and where you come from, and after that, your time to convey your question to Professor Russell. Time's
Okay.
yours.
Okay, thank you. First of all, is my voice audible? Okay. Is my voice audible? Sorry?
Please convey your question now.
Okay. So my questions would be, first of all, I am Fikramar Sapi from Industrial of Engineering. And that was a very bright concept about the efficiency, how do we improve the efficiency of the city logistics by using the physical internet, some sort of agent-based modeling and machine learning and etc. Looking from the POV of manufacturer, from upstream to downstream, that is a very bright concept for the manufacturing company. But how will it will be implemented for a manufacturing company that has already proposed the concept of reverse logistics? The concept your professor has stated before is how will we manage from the upstream to the downstream, and what if we reverse the flow of the materials, so when it came from the downstream to the upstream, how will it will be implemented, and how will the machine learning needs to be changed due to the different flow of materials? Thank you.
Thank you. Yeah, very good question. The work I've talked about this morning is mainly to do with the distribution of parcels and small goods to the final consumer in metropolitan area. But we also know a lot of production, a lot of manufacturing occurs in the cities, and this is a real important type of movement patterns and very important freight operating in the city. So this is a very important area. So we have done modelling to do with production systems and the physical internet and the distribution of the goods to the retailers and warehouse. And again, the physical internet has shown to be very good at resilience, particularly to disruption, but it can be very flexible, because flexible manufacturing is important, and so sometimes the assets will change in their role and function, the products change, the demand changes, and all this is a very dynamic, very fluctuating and changing very quickly, and so the physical internet allows the facilities to be very flexible and to be used in a very flexible way, and if the demand changes or the products change, and the suppliers change and the customers change, the physical internet is able to adapt very quickly, and the utilisation of these terminals, the utilisation of vehicles can be adjusted very quickly. So it's a very flexible way that can, we've done modelling to look at the benefits, and so very similar benefits for manufacturing, for component manufacturing, for final goods manufacturing, and for distribution to warehouses in the finished goods. So this is certainly not just for distribution, urban distribution, even though most of our work. So the actual physical internet came out of Benoit Montreal in Georgia Tech, and actually he has a manufacturing background. He has a manufacturing engineering background, and so this has come up through a more integrated approach to the supply of components, the integration. And so flexible manufacturing, Industry 4.0, for example, is all about information, all about sharing, all about integration. And so the physical internet is an enabling technology for allowing these flexible networks to be established. And so they are very robust, very dynamic, and so certainly you'll find lots of examples of where the physical internet has been studied and the ideas applied and adapted to manufacturing and production. So I think it's a very good area for manufacturing and production to embrace these concepts where they don't have to own facilities, they don't have to own the warehouses, they don't have to own the vehicles, but this flexible, dynamic system of movement can actually facilitate lots of very important aspects associated with the transfer of components and the integration of the manufacturing within cities.
Thank you, Russell. Any feedback from Mas Fikri?
Thank you, Professor. That's clear enough. And I want to add a follow-up question. From the proposed concept, we know that the manufacturer has sent their product onto the depot and blah blah blah. And we know that depot we will pull more than just one manufacturer's. Correct me if I'm wrong. Which means we will do more material handling, which will cause more defection rate of the product. So how will we encourage companies or manufacturing firms to want to be included in this big concept system?
So maybe could you repeat the question? Sorry. Yeah.
Mas Fikri, please once again give your question more clearly. Yeah. And
Okay.
simple question and clearly and louder. Yeah, it's louder. Yeah.
Okay, thank you, Professor. So simply just how will we encourage the manufacturing companies to how we encourage them so that they want to be included in this big system, since we need to give them more steps to deliver their products to the customers, such as pooling and etc., which will cause more material handling and can cause the defection rate of their product. Basically, that was it.
I think the idea is to try and develop these platforms and to try and understand the benefits, because a lot of existing contracts between component suppliers and the movement between the different manufacturing plants is using existing contracts. But with the physical internet, this can be very dynamic, very flexible, and this can be undertaken in a very responsive way. So I think that we have to understand the benefits of this new type of system, and also the storage and it can be modularized, it can be very distributed. So the components can be located in different locations, and they can be accessed very quickly, and so very flexibly. And we know that the technology is changing very quickly. We know that the demand patterns are very different, and we know that the different materials and sometimes shortages. But if we have a very distributed network based on physical internet, it can be far more reliable. We know a lot of costs relate to timing, A lot of the costs relate to coordination, and this is where the physical internet can really benefit because it has a very flexible, very dynamic system of responding to disruption with a synchro modality, but also there. So I think this is the manufacturers should see lots of benefits, potential benefits, because this system does allow all this change and all this dynamic aspects and all this disruption to be the effect to be minimised, and so I think it's a matter of trying to do the modelling to try and work out the different cost benefits and to then try to integrate this. Sometimes we need systems because manufacturers have many suppliers, many component inputs, and so we need to do some work to set up a platform where this can be far more flexible and far more integrated, and that this we can then see the benefits realised.
Okay, maybe a little bit we can elaborate, Prof. Russell. The city logistics system, I think this is a complex system one, and how you consider the combination of the three important components in managing the logistic, including city logistic. First, how to manage the flow of product from the manufacturer to the distributor and so on. The second one, how to manage the issue of information. Yeah. And the last one, how to consider how to manage the issue of finance. Yeah. Finance. Yeah. So this is a simple but complicated one.
Oh, yes.
How you consider in your proposed model to cope with the problem in city logistics? For example, in your case, you already provide in this lecture from the Melbourne case or from the Sydney case as well. Yeah.
Thank you. Very, very complex system, and the physical flow, the information flow, and the financial flow, we all need to integrate. But the physical internet is a very flexible, adaptable concept, and really, I think we need to start with the incentives in terms of the financial, because the costs can go down and the reliability can go up by having a more distributed, a more dynamic system, a more shared system which is responsive, and so then the flow can be coordinated. So we have like Uber operating within the cities in Australia, and it's very flexible. It's very much involving the demand. It can change the pricing, and so I think we need to introduce this concept where the carriers and the shippers can have far more flexible ways of engaging, and but still make profit, still make a good financial incentives. But it can help everyone by having a more responsive and a more dynamic system. So we need platforms to provide that information to the carriers, to the shippers, to see what options there are, and to engage the carriers and to engage the terminal operators in a real time, and to provide incentives so they can price and they can cover their costs, they can make profit. And so we need these systems, and I think it's a new way of thinking, because everyone used to think Uber was not so good, not so going to be useful, but it's very practical. It's very, and it illustrates the power of sharing. It illustrates the power of exchanging and dynamic, and the way that we can start to use resources differently. And so I think this is very important because we know our system's changing very quickly. Disruption can come very quickly. We know the demand patterns change very quickly. And so this new physical internet-based system is far more flexible. And so this is a great opportunity to embrace all this change, all this the different demand patterns, different behaviour, and to set up platforms which can link the different players and provide that financial incentive and the way of interacting and negotiating. And so I think this is a very powerful. It will take some time because we need to start off within the various sectors. We need to start off with we know the parcel one is becoming more attracted, but in production and manufacturing, we need to start off with different sectors because there's different load units, there's different types of assets, but we can set up in the sectors different platforms to connect the players, to allow them to interact and negotiate and allow them to respond and provide the incentives. So it will take time because as we saw with the Alice Roadmap, we're talking about 20, 30 years to get the different types of software, the different infrastructure, the different business models will take time in logistics. So we can't overnight, but we should be trying to encourage with our research and with our development platforms and different ways to try and promote and adapt in small stages how we can embellish these types of concepts. So we can't radically change overnight, but we can introduce elements of physical internet in some of our supply chains, in some of our distribution systems to get this more efficiency. And it will take time to implement the full concept, maybe 20 or 30 years.
Thank you for your very good answer, Prof. Russell. And I hope Mas Fikri already get the idea. Yeah. Okay. We move to the last question. Yeah, from this room. Yeah, because of the time. Yeah. Please introduce your name and where you come from, and then convey your question to Professor Russell. Yeah. Time is yours. Rizky Fauzi. Yeah, okay.
Check. I'm from Industrial Engineering, Universitas Gadjah Mada. Thanks for the presentation, Prof. I have two questions. The first one is, according to you, how if the city logistic is not consider government as a stakeholder, since we know that government have regulatory and also policy, since we know that it's really challenges to build city logistic system. And then the second one is, as you said before, that it is really possible if we integrate logistic distribution with local public transportation. And we'd like to hear your insight for everything that we have to consider to integrate them. That's all my question. Thank you.
Thank you. Very good questions. In terms of government role, I think the government can be a facilitator. As we said, the government can provide some public space for the transfer terminal, small terminal. So this is a new infrastructure, a new type of facility. So the government can provide this area for the vehicles to swap and exchange the goods at various points in the cities. This is a very important role. The government can also provide some facilities for the parcel lockers. So again, to provide some land and provide some infrastructure for these short-term transfers and exchange. And so the government has a very important role in, but also land use, because we know government has the land use zoning, which we try and permit certain type of activities. And so we need some, bring what happens in a lot of cities in the world, and is that the logistics, warehousing, the flexible space, storage space is taken away from the inner city area because the population is coming and it becomes very expensive. And so logistics companies are pushed out to the periphery, to the fringe of the cities. And this is very inefficient because the goods need to move out and then come back to the population, to where the people live. So in Paris, for example, they have a logistics hotel. So the government is working with logistics companies to provide public infrastructure, provide facilities in the centre of Paris to reduce the amount of trucks having to go in and out all the time, and to try and the regulation, we know in Europe, the regulation to do with the low emission zones and zero emission zones are very real. But that works very complicated and introduces lots of costs for the players to upgrade their vehicles that can only operate at certain times. This introduces lots of additional logistics costs, lots of interest, more costs for carriers. And so the government can facilitate. I believe in the city logistics, it's more the free market. So the government can provide some subsidies for the electric vehicles, for parking, for the loading bays, for the loading docks, because it can provide some infrastructure very cheaply and then allows the private sector to become very competitive and good practice. So I don't believe in the regulation is very good for city logistics. I think it's better for government providing some good infrastructure to actually provide the opportunity for embracing the transfers and to utilise the cities. So that's a very important. So your second question on the public transport.
Yeah. What we have to consider in integrating logistic distribution with local public transportation.
Yeah, the crowd shipping is very powerful. I think very powerful model for the to utilise the current public transport passengers to do the crowd shipping. And so this generally relies on some locker system or some way of picking up the goods at the stations. And this can eliminate a lot of the trucks, a lot of the distribution within local area, and rationalise a lot of the freight vehicles by the passengers picking up the goods and being able to take the goods to the final customer. And so this needs some space at the stations for lockers, for the crowd shipper to be able to pick up, to be able to get the access and to be able to do the final delivery. So again, the government needs to provide some facility for parcel lockers for this exchange within the terminals, within the public transport stations and it stops to allow this to happen. And so this is a new type of system of using the parcel lockers for the crowd shippers. And so the government can promote this for small parcels and allow this flexible, because people will be travelling and they can easily accommodate small parcel and deliver to their in their neighbourhood for very maybe no extra trip created, no extra travel. And so the government, I think, has a good role to try and promote this system by providing and facilitating, subsidising the space and the locker facilities at the stations.
I hope you can catch the idea from Professor Russell.
Okay.
So I think it's enough, because
that's enough.
The time.
Yeah. Thank you, Prof.
Okay. Okay. Thank you very much, Mas Rifki Fauzi. Yeah. As the last question of this guest lecture from Professor Russell, and because of the time, before I give back time to the Master of Ceremony, I would like to take this opportunity to again say thank you so much, thank you very much to Professor Russell for your very impressive material, very impressive presentation, lecture, and we can learn from you, very informative, very comprehensive, how to identify the problem of city logistics, how to propose any analysis method to the city logistic problem, and how to promote any best solution for the problem. Yeah, especially you already gave two cases, a case in Melbourne and case in Sydney. Yeah, but because of time, we have to finish this very, very important lecture. Yeah, and the second one, I would like to express my gratitude to all participants. Yeah, both in this offline room and in Zoom room as well. Yeah, for your very active, for your very nice collaboration, for your participation in this very, very important lecture from Professor Russell. I'm very pleased. I'm very excited to be the moderator in this international guest lecture. Thank you very much, and I give back the time to Master of Ceremony. Thank you so much. Yeah.
Thank you very much, Professor Kunchoro and also Professor Russell Thompson, for the very intriguing materials and presentation. Let's give another round of applause for our presenters and moderator. Professor Russell Thompson and also Professor Kunchoro, you're allowed to please go back to your respective seat. As we near the conclusion of today's event, allow me to express our heartfelt gratitude to all of our speakers, moderators, and participants for their invaluable contributions to our discussions. Before we conclude this event, we have an exciting moment to announce the lucky winners of our door prizes to all the participants who have asked some questions. So to all of the participants who I'll be calling their names, you are allowed to please come to the front as we'll have a door prize giving session. So the first one is Mas Ananda, please. Second is Mas Chegi, and the third is Mas Rizky Fauzi. And for our online participants, the door prize is awarded to, the first one is Mas Rudi Aliansya, and the second is Mas Fikri Amori. Thank you very much, everyone. We'd like to kindly ask you to please return to your seat as you will have a photo session with everyone in the room. Ladies and gentlemen, before we conclude the event, we will have a short photo session with all of the participants gathered here. So ladies and gentlemen, please sit tight and show your best appearance as our cameraman will take a picture of everyone in the room. Oh, please stand up, sorry. Thank you very much, everyone. On behalf of Universitas Gadjah Mada and the Department of Civil and Environmental Engineering, I would like to extend our sincere thanks to each and every one of you for your active participation and engagement throughout this event. We hope you found the discussions enriching and also inspiring. As we bid farewell, let's carry forward the lessons learned and connections made to pave the way for future collaborations and innovations. Ladies and gentlemen, thank you for your participation. Until we meet again, thank you and goodbye.
Transportasi adalah sektor penting dengan berbagai isu dan permasalahan yang tidak pernah habis. Berbagai isu yang perlu mendapatkan perhatian di antaranya adalah meningkatnya jumlah pergerakan orang dan barang, perubahan pola bepergian, tuntutan kualitas penyelenggaraan transportasi yang efisien, inovasi teknologi transportasi dan informasi, transportasi yang berkelanjutan, serta pola pemanfaatan ruang yang optimal. Universitas Gadjah Mada memiliki keragaman disiplin ilmu dan kualitas peneliti yang prima, yang menjadi aset utama menjawab permasalahan dan tantangan tersebut. Pusat Studi Transportasi dan Logistik adalah lembaga penelitian di bawah Universitas Gadjah Mada yang didirikan pada 3 Juli 2001 dengan tujuan untuk memberikan solusi atas permasalahan transportasi dan logistik yang lebih kompleks saat ini maupun masa yang akan datang. Pustral didirikan dengan kolaborasi beberapa fakultas di UGM, di antaranya Fakultas Teknik, Fakultas Ekonomika dan Bisnis, Fakultas Geografi, Fakultas MIPA, serta Fakultas Ilmu Sosial dan Ilmu Politik.
Visi Pustral UGM adalah melaksanakan visi Universitas Gadjah Mada untuk mewujudkan pusat studi dalam bidang transportasi dan logistik yang unggul, inovatif, berkelas dunia untuk kepentingan bangsa dan kemanusiaan. Misi Pustral UGM adalah melaksanakan penelitian bidang transportasi dan logistik untuk mendukung pengembangan pendidikan dan pengabdian masyarakat.
Tujuan: melaksanakan penelitian bidang transportasi dan logistik yang berkualitas sebagai rujukan nasional maupun internasional. Mendukung penelitian-penelitian yang memberikan kemanfaatan hasil penelitian bagi peningkatan pengetahuan di bidang transportasi dan logistik yang bermanfaat bagi kepentingan akademik. Melakukan pengabdian masyarakat dengan kualitas prima dalam membantu berbagai institusi yang membutuhkan layanan, khususnya dalam bidang transportasi dan logistik. Memperkuat tata kelola pusat studi dalam menghadapi berbagai perubahan, baik di dalam maupun di luar, dan memperkuat jejaring bidang keahlian, infrastruktur, sistem dan manajemen, kebijakan, kelembagaan dan regulasi, sosial, budaya, keselamatan dan lingkungan, ekonomi dan bisnis, telematika dan sistem informasi. Pustral memiliki berbagai aktivitas untuk menjalankan visi dan misi berupa kegiatan pendidikan, penelitian dan pengabdian kepada masyarakat. Kegiatan pendidikan berupa pelatihan dengan berbagai topik, perencanaan transportasi, angkutan barang, sistem informasi geografis, drone, unmanned aerial vehicle, serta berbagai jenis pelatihan lainnya. Dalam rentang waktu yang panjang, Pustral telah menghasilkan beberapa rekomendasi yang telah diterapkan. Kebijakan-kebijakan terkait transportasi perkotaan, perencanaan kawasan Malioboro, pengembangan bandar udara di Yogyakarta, Bali, Surabaya, perencanaan kawasan industri, pengembangan pelabuhan laut, pengembangan transportasi kereta api. Salah satu rangkaian produk penelitian adalah terbitnya buku dan paper. Pustral telah menerbitkan beberapa buku terkait dengan perkembangan kota, angkutan umum, logistik perkotaan, terminal barang, uji laik fungsi jalan, dan kajian kritis pembangunan jalan tol di Indonesia. Pustral terus mendorong agar penerbitan buku dapat terus bertambah di masa mendatang. Pustral juga berpartisipasi dengan mengirimkan paper dalam berbagai konferensi, serta penerbitan di berbagai jurnal baik di dalam maupun luar negeri. Sebagai salah satu wujud pengabdian kepada masyarakat, Pustral menyelenggarakan berbagai sesi diskusi dan seminar, baik berupa seminar offline maupun online. Pustral juga terbuka memberi masukan dan edukasi dalam bentuk wawancara maupun tulisan populer di media massa. Dalam kiprahnya, Pustral membangun jaringan dengan berbagai pihak dari dalam maupun luar negeri. Pemerintah, swasta, badan usaha milik negara, lembaga donor internasional. Pustral juga menjadi anggota berbagai asosiasi profesi dan keahlian, di antaranya Forum Studi Transportasi Antar Perguruan Tinggi, Masyarakat Transportasi Indonesia, Masyarakat Perkeretaapian Indonesia. Untuk memperkuat kelembagaan dan meningkatkan kualitas sumber daya manusia, Pustral menyelenggarakan pelatihan, studi banding, dan rapat kerja internal. Untuk membentuk kebersamaan, Pustral menyelenggarakan family gathering dengan melibatkan seluruh karyawan beserta keluarga. Kedepan, Pustral optimis bahwa transportasi dan logistik yang bersinergi dengan sistem informasi akan menjadi sektor yang strategis dengan perkembangan paling pesat di Indonesia. Bersama Pustral, kita membangun transportasi